have to do is we have to go up to the ice cache that we've created before. And also, we have this water cache here, and by the time that we want to shatter it, this just turns into nothing. So what we need to do is just make a null here because we will be using this later. We're just going to do out water, and we can just kind of let this sit for a bit. And instead we are just going to be focusing solely on the ice cache. So let's just kind of give this a scrub, see what it looks like. Alright. So we will be calling this ice as well later, so we're just going to do null out ice. So we don't let's see where this stops animating. Looks like around frame 82 is where it stops growing. So we're just gonna freeze this. So I'm gonna do a null, or no, sorry, not a null, time shift. Because we don't need this to cook at all past frame 1083. So I'm gonna go up to frame here. I'm just gonna kill that. And then now what we need is we need a separation between this giant chunk of ice that we have here and the frozen water ice here, so that the stuff around it can break away, but we keep the ice as is. So to do that, we are going to do a Boolean. Then we need a sphere. We're going to have to transform the sphere. And we will be putting noise on it, so I'll just go up here, copy our noise. Just come in super handy, just having that floating out there. Again, it's good to make your own tool, but since this isn't a tutorial on how to make tools, you probably already know how to do it. We're just going to copy this. So if we look at this and then have that. So our sphere is pretty big. We're going to want this to be probably a scale of 0. I have it at 0.41. Let's see how that looks. I've got to connect this. It's probably good. And then the sphere itself. Okay, so that's the sphere. So actually I want this to be the uniform scale here, 4:1. And we'll leave this at 1 for now. And then for the transform, I'm going to transform this up in the Y to 2.3. Might not cover enough, but we'll see. And then scale, we're going to scale it up in the Y to 1.6. So that's not big enough, but it's almost big enough. So we can just take the uniform scale here and we'll crank this up to, let's see, make sure it's totally enveloped. So 1.25. And then we'll see here what this looks like. Oh yeah, also we need to change this to polygons, and then we need to up the frequency pretty significantly. We're gonna do, I'm gonna make this, actually another thing that we want is, I think it'll be good for Boolean to have quads to work with, so I'm gonna do polygon mesh, and then I'm gonna make rows 100 and columns 100. And then as for the noise, we're going to change the frequency to something like, let's do 6. Then amplitude, we want it to be more, so let's say 2, 3, 4. Probably gonna work. We can reduce the roughness because now we're getting some pretty jagged edges that I don't know how the Boolean's gonna handle, so let's just bring it down a little bit. We'll just make it 3. That should probably work. So now this is going to cut out our ice and leave behind our bowl of ice. So both of these should be solid, and then we're just going to do a simple Boolean shatter. It's got to think about it. I think it usually starts with intersect. no, it does subtract. We don't want subtract in this operation here. We want shatter. And they're both solids, so they should remain as solids in the treat as. Now if we look here, we can see that it has been cut. There is this line going around. And now we're just left with the ice. And then this bowl of ice, so the crystals in the bowl. One thing that we do need to do, however, is we want just A pieces. And so there's the A shape here, and then the B shape here. We just want the A just as a group, and then we can cut between the two. So I got to turn that on here. Alright, now we do have a prim group of A pieces. So let's just, I like to err on the side of caution when it comes to caches. It gets a little complicated if you pass this off to other people, but since you're not, it's fine to be caching things out. We don't want to ever have this Boolean need to cook again. So I'm just going to write it out and make sure that it doesn't. So Boolean ice. Anything that needs to cook and then impact you down the line, you usually want to cache that out so that you aren't waiting. And then this will just be current frame. We don't need $F because this is not going to be animated. So we will just make sure that looks good. Yep, save to disk. And we're good. And now if I scrub, doesn't matter where I go. Alright, so I'm coming back from the future real quick. I'd found that the Boolean actually kind of messed up. So the reason that it messed up, and I'll just kind of go over this, is so when I created the noise on this, the amplitude was too great. And so when you have these strange sort of self-intersections, when it goes to the Boolean and you have solid objects instead of surfaces, things get kind of weird. And so it did create A pieces, but it didn't create them correctly. So what you want to do is when you have your cutting geo, you want to make sure that it's not really intersecting itself, and you can see that it's already doing that there. So I just made sure that this noise isn't too terribly great. And if we need more noise, we can add it later, but we don't want our Boolean to be too noisy when it comes to solid-based Boolean cutting. So now if I go back to this Boolean, it's going to think for a second. We have our cut. I'm just going to put this to the side, and I'm going to put down a split because we will be needing the split. And if I go here and do A pieces, now this should work. Okay, this works exactly how I want it. Before, I was getting just one chunk of stuff, and that's all because the noise was too great. And then another thing that I found is when you're writing out something like a Boolean, maybe write it out after you're certain that it works, because I got hung up a little bit making changes up here, changing the Boolean, going down to the split. However, there was this cache here, and so this cache, you can see, this is what I was getting from the A pieces. So now if I write what I have newly, then this works. So things to remember when you're file caching, make sure it's good to go so that you aren't changing things up top, expecting it to pass through, and then having it not do anything differently. Yeah, it's easy to waste a lot of time doing that. It's one of those gotchas that Houdini has that you bring it on yourself, but it's just a hassle. Okay, so we have this cut now. We have the water here that's supposed, well, it's ice water. It's kind of hard to define this because I've got the ice crystals, I've got the ice water. This area here is what we want to shatter, and everything else is just going to branch off. So we're going to focus on this left side right now. And so first what we need to do is we need to create points from volume. And And man, I hate points from volume and how it gives you this blue thing. So what I will need to do now is put another node beneath it so I can actually see what the hell I'm doing. And there is actually a way to get rid of this, but it gets rid of every sort of template geometry representation. And sometimes you'll forget to turn it back on and think that everything's broken. So it's not a good solution. I'd rather go through the steps of putting stuff beneath this than turning it off and then forgetting that I did that later and then ruining Houdini for a while. So I'm going to put down an attrib randomize. Okay, so now I can see my points here. So for point separation, we probably have too many points, so I'm going to make it 0.15. And we are going to make the jitter scale 10. Rarely do I want a perfect grid. So we look here, now we have a decent amount of points. And I'm going to now do a copy to points. And then I'm going to create a grid. I'm going to plug that in and we'll see. So this isn't what we want, but that's because we haven't done anything with the attribute randomize yet. So things are copied to points according to the normal that they have, so we need to randomize the normal. So we're going to go to attribute name, we're going to make that n. And this still isn't what we want because it just has a uniform distribution. We want inside sphere. And now we have a whole lot of cutters. But we're going to need to change it up a little bit. So the size, it's too large. We only want this to be 0.8. Let's just look here to see. Yeah, so that's much better. This is totally enveloping our geo, but it's not too insanely large. And then we want more rows on this, so instead of 10, I'm going to do 40 and then 40 for rows and columns. And then I'm also going to rotate these to that, because everything's sort of dependent on the z-axis when you're copying the points. And yeah, I think that's going to look good for our cuts. However, there is going to be one issue. You can see here, look at this gigantic piece right here. Like there's a lot of pieces that are going to be large and sort of left out on the edges. We'll get good chunks, but we don't have quite enough cut up. And so when this actually does fracture, these little bits are going to be huge and floating up, having not been fractured completely. And so there's a way that I found that's actually pretty simple that ensures that we have these edge pieces in nice fractured ways. So we're going to do just a scatter. We already have stuff throughout the volume, but we want to make sure that the surface of these edges are cut up. So I'm going to take the scatter, plug that in. So we don't need too many points here. I'm going to do 75 instead of 1,000. And so then what I'm going to do is I'm going to create a point wrangle. And so what I was saying before about the normals dictating how these things are copied, what I'm going to do, also I'm just going to, no, this should be fine. I think I might up this a little bit, so I'm going to make this 85. Should be fine. So we need normals on these, and we need it so that all the grids are facing inward. And so this will slice it sort of like a pizza. And in order, you'll see what I mean in a second. So I'll do at n, so the normal, equals the position of each point that I've just scattered minus the centroid of this whole object of water. So get b box, so it gets the bound of the object, and then you can just say center, and so this gives you the centroid of that bounding box. So now when I do that and I show the normals, We can see that everything's facing out. That's fine. Doesn't matter if they're facing out or in. They just need to be in this outward projection. And that looks good. So I'm just going to merge these. So now it's not going to look a whole lot different, but now we can see that we have this sort of pizza cutting of the edge. So that ensures that we don't have any strange large chunks on the outside. And so then now we want to take our noise, as we have been doing a lot, because we want to noise these up. We don't want perfect slices. So after we've put everything there, I'm going to put this here. And so we're going to, I mean, this is mostly good. We're going to increase the frequency, and then the amplitude can go up. Since this is a surface, it's going to be a little bit more forgiving for what we're going to do next, which is a Boolean fracture. And so if I drop a Boolean fracture, just going to put this here, going to do a little management here so things aren't crisscrossing. And so I'm going to just save. Usually it's good to save before Booleans and stuff, because you never know. I'm going to plug that in, and now this is going to dice up our ice. So this fracture takes a little while. So again, when it comes to Booleans, it's probably good practice to save things out. I'm also seeing things that may or may not be right. This should probably be fine. It's going to fracture fast enough that we're not going to notice any little tiny chips here. And it could just have to do with the normals. So I think that's acceptable. I think, yeah, I think once we actually shade it, it's not going to look too strange. So we'll go with it. It could just be that there's too much noise, but I think it's fine. So we're going to do a file cache, because again, we don't want to have to wait for this to cut all the time. Ice. We'll call this fractured ice. We'll do load from disk, do the whole spiel. We'll just save current frame. Actually, well, this should be fine. Actually, no, I'm going to get rid of this. Because since it's a single frame, we don't want the frame in there.